Hi everyone, today we are going to solve differential equations of order 1 using TI-84 plus CE Euler's method. So we will take one example. So first example is differential equation is x plus 2y square, where the initial condition is 1 comma 1.5 and step size is 0.1, where we have to approximate value real curve at 2. Now keep in mind the Euler's general formula which we have discussed in the previous lesson. So next x coordinate can be found by previous x coordinate. The present x coordinate which is given here is 1 and plus step size. Similarly, next y coordinate can be found by the present y coordinate plus the step size times the gradient of the curve at the previous point. Now we have to keep in mind few points like x and y are replaced by u and v in GDC. GDC does not take x and y. So x is equivalent to u in GDC, y is equivalent to v in GDC, and n is a variable in GDC, not x. We'll see that when we are going to use GDC. Okay, so first step is take out your GDC, press mode and select sequence. Scroll down and select sequence, enter. Now press y equal to. Now there are different types of sequence. You can see sequence type is n with n plus 1, we're starting with n plus 2. So but it's ideal to use sequence starting with n plus 1. So next term with n plus 1 plus 1 represents next term. So previous term is un. So how do we find by Euler's method? X n plus step size. So we'll use un plus step size. Step size is 0.1. So where is u? We press second 7 and the variable is by the right hand side of the green button, alpha. So brackets, that is variable is n, and then plus step size 0.1, that is given in the question. We move on to the next. Now the x value, the u0 means the initial x value is given to be 1. So we enter 1, keep u1 blank. Then next y value is v n plus 1. So because v is equivalent to y in calculator in GDC, so how do we find the previous y value, that is yn? So here vn. So press second followed by 8 and press the brackets, then the variable n, close the brackets, plus step size, that is 0.1. In our curve 0.1 times we have the curve x plus 2y square, so that means un plus 2yn square. So we use the brackets un second, u in the bracket, variable n, plus 2 times in the bracket second followed by 8, that is v, in the bracket n, variable n, close the bracket, again close the bracket, squared, and then close the bracket, and that is how we enter. Okay, now we have the initial y value is 1.5, so v represents y here, so 1.5 initial y value. And then after entering all these values, we can use second graph and we can see all the values of u and v are displayed, and we are supposed to find what value of y at x equal to 2. So we can see the value of x y at 2 is 3.9 into 10 raised to power 26. Now we can plot the scatter also for these discrete points. So what we need to do, we have to store these in L1 and L2. So operation number 5. Now we have to store the sequence un and vn. So we first store the first sequence, let's say un, so second followed by 7, u in the bracket, variable n, and then the variable is n, and then we start with 0 and end with 10, and step size is 1, and then we paste and then we enter. Now these all are the steps, values of the x values. Now we have to store that. So here is the store button, and then second stat and store at L1. So we can enter. Now we can go to stat and see is it stored in the edit. So all these values are stored here. Again we go to mode, second, stat, operation OPS, I mean 5, and now instead of u we replace u by v. So v of variable n, and the variable is n, step size 0. We can keep the n point 10 and step size, so we can enter these values, and we can save all the y values and store, and then press second, stat, where we want to store at L2. So we can enter L2, and these values you can check are stored. These values are stored. Stat, add it, and we can instead of sequences we can select the function, and then we press second, y equal to, press plots on, then we can go to window, and our minimum window is 0, and we can enter 0, and maximum we can select is 2, because the maximum by x value is 2, which we have to, and the step size is 0.1, and minimum value is 0, maximum y value we can check is 40, and scale is 5, and then we can press, we can trace also, we can see the values at x1 1.5, x 1.1 1.2 1.4 is 9.8, and likewise we can see at 1.9, at 1.9, and then 2 3.9 into 10 raised to 26, which we have already calculated before. So in this way we can, it can help us to compare the real curve and the Euler's discrete points. Thank you.